this computer. All right, so any questions? Okay, so shall we start? Chapter 1 is intro questions. Chapter 1 is introduction of forecasting. Topic includes the history of forecasting. If the forecasting is necessary, types of forecasting, macro forecasting considerations, and the forecasting method. We'll talk about detail about forecasting method actually in chapter 3. Okay. The steps and the process in forecasting, some forecasting softwares and examples. Okay, so those are the chapter 1. And for the forecasting history, before 17th century, forecasting does not have a good name. Okay, most people consider forecasting is a waste of time. Some people even consider forecasting is a sin. Okay, that is before 17th century. Over the past 300 years, forecasting is data-based. For example, people get the data and do data manipulations using formulas or equations or techniques to make forecasting, such as the smoothing, decomposition, regression, and ARIMA. Over the past actually 25 to 30 years, not only based on the quantitative forecasting, but people also use qualitative forecasting, means the manager or the people's judgment or based on the expert knowledge will incorporate it into the forecasting. Therefore, forecasting is a combination of objectives, methods, assessment, and even conclusions. Okay, combine those aspects together to make final decisions. And also information technology play a huge factor in making forecasting. So those are the forecasting brief history. The question, is forecasting necessary? Actually, everyone needs forecasting. Okay, even for example, the weather forecasting, we know we all need weather forecasting. Same thing, if you are the manager or CEO of a company, you need to know how many products you need to produce, and you need to know what are the price for the project, for your product. Okay, so forecasting is useful when it is in uncertainty. Okay, information, of course, is an asset. We use information to make a forecast. Okay. The information sometimes is not reliable. We use reliable information about the futures. Some information, it is just speculations. We need reliable information, solid information as a source for competitive edge. Forecasting supplements include the judgment from decision makers combined with the quantitative forecasting techniques. The types of forecasting based on different levels. If you consider the time frame, we divide the forecasting to short-term forecasting versus long-term. Usually, if it is 6 months or less, that is short-term. Above 6 months, it is long-term forecasting. So that is based on the time. If you divide the forecasting based on the detailed levels, we have macro forecasting or macro. For example, a company may consider how many employees it will hire. That is the micro, very detailed. I need 10 employees, or I need 25 employees based on my production. On another hand, the government of Canada need to forecast, need to know the unemployment rate, okay, unemployment rate, or need to know how many people on the labor market. That is the macro. It is overall, general. And then forecasting can be divided by quantitative and quantitative. This is a typo, okay? Quantitative and qualitative. We based on, if the forecasting is based on the data and the data-driven methodology, that is the quantitative. If the forecasting is based on experts' opinion, okay, CEO or manager's judgment, that is the qualitative forecast. And from the outcome of the forecast, we divide the forecast to point forecast. For example, we want to forecast the average sales of our product, okay, for next year. Maybe you can use this year's average sales to forecast next year's forecast. So that is the point, okay? This year, maybe you sell 30 million products. Next year, you anticipate you will also sell 30 million. That is the point. The interval, you make it a range. For example, this year you sell 30 million products. Next year, maybe between 28 million and 31 million. This is an interval. Okay. And the density forecast is based on the probability distributions. So those are the types of forecast depending on different point of view. The models for the cost forecast, different textbooks have different categories. Our textbook uses these 4 categories. The forecast model could be the naive model, okay? So for example, you anticipate next year's sales equal to this year's sales, okay? That is the naive models. And another important model is the time series. When we talk about the time series, usually we use the moving average, okay? We use the, for example, 3-period moving average. Means you average the 3 months sales, okay? And to using that moving average to anticipate next month's sales. And we always use the weighted, the most recent date has more values, okay? For example, last month's data is more important than 2 years ago, a month in 2 years ago. We put more weight on the most recent data. And the last method for time series, we use decomposition. Time series data usually have the trend. And also sometimes the data has a seasonality. For example, the energy sector. During the winter and the summer, we tend to consume more energy, okay? That is the seasonal factors, okay? And also the index. So usually we decompose the forecast by those 3 components, trend, seasonal, and index. We'll talk about details in chapter 3. So those are the time series. And for the associative method, we talked about correlation analysis. We want to explore if one variable, how one variable related to another variable, X related to Y. And this correlation can be expressed, can be conducted using regression analysis. When you use regression analysis, the independent variable X could be 1X, like this 1X, or could be have multiple X, X1, X2, or X3. Okay. Finally, there is a famous forecasting model, Box-Jacobs, also called ARIMA. ARIMA stands for auto-regression integrated with moving average. We'll talk about that toward the end of the week, the semester. So those are the overview of forecasting models. Any questions?
Yeah, hi, Professor.
Yes.
So what does the I, S, and I stand for again?
IS, oh, okay. Decomposition, this T represents the trend, this S seasonal. For example, spring, summer, autumn, winter, 4 seasons. And this I represents index. Okay, we'll talk about the details in chapter 3, chapter 5 actually. Any other questions? Elizabeth, you have questions? You raise your hand. Right. So that is chapter 1, okay, overview of forecasting, including those topics. Now chapter 2 is pretty specific about review of basic statistics. I hope maybe you already took, most of you already took CQMS1 or 2, CQMS2 or 2, but maybe you forget something. This is a good chance to review. Make sure you know how to calculate the average, okay? You add all the number together, divided by sample size, that is the average. And how do you calculate the Z-score? Okay, some students always have question, what exactly is the Z value? Z value. The Z value is a measurement. I will give you example. For example, your body weight can be measured in kilogram. Your body weight can also be measured in pound, okay? Can also be measured in pounds. There are 2 different measures, but they measure the same body weight of you. If you get, for example, your weight is, let's say, 65 kilogram. So 65, if you use kilogram, is 65. But if you use pounds, it may be, you can Google, 1 kg equal to maybe 2.2 pounds, okay? And then you need to 65 times 2.2, just to do the calculation. So 143. So if you measure in the pounds, your body weight is 143 pounds. You see different numbers, but they represent the same body weight. Same thing here, the Z-score, it is just take the average as 0. For example, the average age of the students right now, I consider that average is 0. Based on, for example, the average age for this class, I guess 22 years old. Maybe I am wrong, okay? So the average age for this class is 22 years old. That is my regular X. Each student, you have maybe some students 25 years old, some students 18, 19, etc. But if I say the average age 22 years old is 0, then if your age is 23 years old, you are here, you are greater than 0. If your age is 18 years old, you are here on the left-hand side of this 0, okay? So that is the Z-score. Take the average as 0, and then other numbers compared with this average. That is the Z-score, okay? And also the relative location, okay? And if the average is 22 years old, And if your age is 24 years old, you want to know maybe how much percentage of the students younger than you. That is the location. Where are you located in this class? Okay. And this S is a standard deviation. Measure the spread. Measure the spread. Is the data spread all over the place, or is data more concentrated? If it is spread all over the place, you have a bigger standard deviation. If data is more concentrated, you have a smaller standard deviation. Okay. For example, in the stock market, if you are a risk taker, you want the bigger standard deviation, because when you win a lot. Okay. But on the other hand, if you lose, you also lose a lot of money. Okay. A conservative investor maybe choose a standard deviation, the stock that has a standard deviation small. Okay. Because when you lose, you don't lose that much. Okay. So those are some concepts. The interquartile range is Q3 minus Q1. What is Q3? Q3 is the third quartile, means 75% of the data smaller than Q3. Okay, and Q1 is the first quartile, means 25% of the data smaller than Q1. Okay, and we use IQR to measure the range, the spread of the data. Okay, so those are the basics from QMS703. And this box plot has the present the 5 number summary. There are 5 important numbers to describe a data set. Those 5 numbers are minimum number, maximum number, okay. And the first quartile here, we use Q1. Median is second quartile, Q2. Third quartile, Q3. So those are the 5 important numbers: minimum, maximum, Q1, Q2, Q3. If I give you a set of data, by just looking at data, you don't get any information. But if I present this data in 5 number summary, you have a clear idea what is maximum, what is the minimum, okay, what is the midpoint, what is the midpoint. Okay. And based on this midpoint, maybe the data is this layout, we call this is skewed to the right because it has a longer right tail, skewed to the right. And maybe data is this. And this is skewed to the left. You have a longer left tail. Or the data may be bell-shaped. If you put the data into those distribution, it is either one of those, skewed to right, skewed to left, or bell-shaped. We call this bell-shaped is the normal distribution. And this is the data set we love to dealing with. Any questions? All right. So this diagram shows the monthly sales. Imagine you are in a food store, monthly sales. It is from year 2002 to year maybe 2006. Okay. And during each year, it has the monthly sales. They put the data. Y-axis is the sales. Okay. And observe this data in time series. You can see the data has peaks. Those are the peaks. Okay. And you also have the data has the valleys. Okay, those points. And you also see the range between peaks and valleys. Okay. And over the time, this is a typical data for time series. Although it has peaks, valleys, but looks like data are changed around this line. This is the trend line. Okay. So this is how do we analyze the monthly sales? And if you make forecasting, for example, 2007, maybe it will go this way, etc., etc. Okay, it is just this pattern. We'll study the specific forecasting techniques later. Okay. Here you just get the idea. The data can be presented into the curve. Okay. And continue with this one, actually continue with the review of basic statistics. We already did that, except the expected values. Expected values refer to the random variables. We don't know its value. We use expected value, okay? You use random variable x times the probability of random variable, add them together. That is the expected value. So in this chapter, we also need to review the correlation coefficient to measure the relationship between two variables. One variable is x, the other variable is y. We use the correlation coefficient R to measure the relationship between x and y. Okay, if you have a scatter plot of x, y is this, means when you increase x, y also increase. You have a positive correlation coefficient. And if the scatter plot between x, y, something like this, you have negative correlation coefficient. Means when you increase x, y decrease. Okay, and how do you calculate this correlation coefficient? You use this formula. In this formula, the Zx means the Z value of x, you need to translate x value into Z value. How do you translate? Use x minus x bar divided by standard deviation. You get Z value for x. Okay, and when you use Excel, you have a formula in Excel. I will talk about that when we go to the example. The method of least squares criteria, we use this SSE, okay? Sum of square due to error. This E is error, E-R-R-O-R. Sum of square due to error. By definition, it is use original y minus this y hat represent predicted y. And where the predicted y come from, it will come from an equation. It will come from an equation. And that equation needs slope and intercept. Once you have a slope, you have intercept, you can write an equation. Okay, and you have equation, plug in x, you can produce a y. And that y is predicted based on the result of the equation. Okay, subtract from original y, square it, do this procedure for all the points, add them together, you get the sum of square due to error. In forecast, we want this SSE, the smaller, the better. When you do forecasting, you usually use several different methods. Okay, for example, 3 different methods to forecast. Which method is the best? There are several factors. One factor is which method will produce the smallest SSE. The smallest SSE indicate that is a good model, good forecasting technique. We talked about the expected value and the binomial probability distribution. Binomial probability distribution dealing with a situation where you only have two outcomes, just two outcomes. For example, after you graduate, you either found a job or you do not find a job. Okay, right now, you either have a student loan or you do not have a student loan outcomes, or you either are domestic students or you are international students. Those are two outcomes. In this situation, the question asks, for example, the probability of having a student loan is 45%. The probability of having student loan, 45%. Now you randomly selected 35 students. You want to know what is the probability that randomly selected 35 students have student loan. That question can be answered using binomial distribution. Okay, and we talked about the z-score. Sometimes the z-score has a different formula, x minus x bar divided by s. The difference between these two formulas is that the first formula using the sample data, and the second formula uses population data. If you see the simple mu, that is the population mean. If you see symbol sigma, that is population standard deviation. Okay. So the first formula, x bar represents sample mean, s represents sample standard deviation. Okay. So use different notation represent, you use different data source. One is use sample data, the other is use population data. Okay. Any questions so far? All right. So now let's do an example. Just make sure you can see, okay, you can see the whole example. Yes. So this example is calculate the point and the interval estimates. Remember in chapter 1, the forecasting outcome could be point, or the forecasting outcome could be interval. So let's do this question. A random sample of 500 shoppers is selected from shopping center to determine the average distance they traveled to the mall. An analysis of sample revealed that sample mean is 23.5 miles and the sample standard deviation 10.4 miles. Okay, 10.4 miles. Suppose we are using 95% confidence level. This is commonly used confidence level. Other commonly used confidence level is 90% or 99%. So for this example, I give you 95% confidence level. So what you are asked to do, based on the sample data, estimate population mean. Based on sample data, estimate population mean distance for all, because it is population, so it is referred to all shoppers. In two formats, one, point estimate. Another one is interval. So you are asked two questions. One, what is the point estimate for population mean? Question two, what is the interval estimate for population mean? the two questions based on the same sample data set. And the two questions are targeting population, not sample. Why not sample? We already know sample information. Sample mean is 23.5, sample standard deviation 10.4. But we don't know population. What is population mean? That is question A, point estimate. What is the population interval estimate? That is question B. Okay, so first we analyze the question, what is given? Given sample data. What we are asked to do, answer two questions. Question A, what is the point estimate? So if you recall CQMS703, the best point estimate for population is sample average, use sample mean. So the answer for question A, what is the point estimate for population mean? The answer is 23.5 miles. Okay, this is actually, you can call naive model. You use sample mean, represent population mean. We answer the first question. What is population mean? The answer is 23.5. Okay, any questions so far? Now let's move on. Question B, what is the interval estimate for population mean? Means what is the average miles from which number to which number? We need two numbers. Okay, how do we get two numbers? We use this formula. Okay, the lower bound, we use x bar minus z times s over square root of n. This is lower bound. Upper bound, we use x bar plus z times s over square root of n. So we produce two numbers. Okay, and what is the z? Remember in QMS703, z is the critical value. Okay, critical value. What is a critical value? Critical value is a point that decided by this 95%. So if you have a normal distribution, 95% means the central area is 95%. So this area is 95%. Area. The critical value is, what is this point? These points are critical value. As you can see, I have two critical values. One is positive, the other is negative, because this is a standard normal distribution. When you have standard normal distribution, the mean is always 0. This middle point is 0. Okay, the average is 0, mean is 0. Now you want to find out what is this critical value. Okay, so to find that, you need this knowledge. Okay, given a percentage confidence interval, how do you find this critical value? Okay, if you use the calculator, the Casio calculator, go ahead to use it. Okay, if not, everybody can access Excel, but not everybody access that calculator. So now I'm going to introduce Excel method. Okay, so I hope you can see the Excel. Try to manage the window so that and also I try to increase just, maybe I need to open a new Excel workbook, and then I will increase the font size so that you can see the formula I entered. So I just need this cell. So in Excel, you type in norm, means normal distribution, okay, and dot INV, okay, means critical value. critical value. After that, you are given probability. So I'm going to type in the probability, then I will explain, okay? I will type in 97.5%, and then mean is 0, standard deviation is 1. Okay. All right, I'm going to give you the formula, then I will explain what I typed in. So this is the formula I typed in Excel, and the result, you will get 1.96. Now I will explain why this is 97.5%. The Excel is based on area to the left. The 95% is the area in the central. In order to find this point, I need area to the left of this point. I need the whole area to the left of this point. Okay, so think about this. If this middle, the central part is 95%, and we all know the whole area under the bell-shaped curve equal to 1. All the area under the bell-shaped curve is 1. If the central part is 95%, you tell me, what is this little left tail? What is this area? The left tail area. Anyone?
It will be 0.025.
2.5%, you mean?
Yes,
Excellent.
2.5%.
This left tail is 2.5%. Excellent, fantastic. Thank you for your participation. So if the central area 95%, this little left tail area 2.5%. Okay, now you tell me, what is the point? What is the area to the left of this point? What is this area here? Anyone? You have this central is 95 and this little tail 2.5. So come together. What is the whole area on the left-hand side of here? Anyone? What is the area?
Yeah, it'd be 97.5.
Thank you so much. This area would be 97.5%. So now, do you understand why I type in 97.5% in my Excel formula? Because Excel is based on area to the left. Okay, that's how I get the critical value 1.96 based on Excel. Okay, so in class, I give you 95%. Maybe during the test too, I give you 93% or 87% or any percentage. You should know how to find the critical value. Is that clear? So that is how the test question coming from. Usually it is coming from the class examples. I just changed the numbers. Okay, do you want me to give you an example, not 95, any percentage, and then calculate critical value?
Sure, yeah, go ahead.
Thank you. And I need your help. Can somebody give me a number, not 95%, not 99%, not 90%, any percentage? Makes sense. That percentage makes sense.
87%.
Thank you so much. 87%. Okay, let's do it together. So if you give me the 87%, means this is 87%. The question is, what is this point? this point is the critical value. Okay, okay. So based on this is 87%. What is this little left tail area? 13% divided by 2. Do you agree? Or
Yes.
6.5%. Okay, so this little tail, left tail area, 6.5%. And now, what is the area on the left of this point? You use 87% plus 6.5%. The answer is 93.5%. Do you agree? This area is 93.5% on the left side of this point.
Yeah.
Great. Once you have this 93.5%, you go to Excel, just change this 97.5% to 93.5%, you will get this point. Just go to Excel. And then in this formula, instead of 97.5, you change it to 93.5%. 93.5%, okay? And you will get the result. I want to show you the Excel. So the result is 1.51. Okay, 1.51. So that is how you found the critical value without calculator, without table, just based on Excel, because everybody access Excel. If you have calculator, go ahead using your statistical calculator. Okay. So we solved the question for what is this critical value. Once you have this critical value, go back to our question. We want to find out lower limit. I'm going to erase this one because our focus now is what is the interval estimate. For interval estimate, you need lower bound, upper bound. So lower bound, it is just a formula, x bar minus z times s. What is z again? Z is 1.96. What is s? S is 10.4. What is x bar? X bar 23.5. What is sample size n? N is 500. Okay, you have every number, you know all the number in this formula. You know all the number in this formula. You can find the lower bound. Okay, so the lower bound is 22.6. So similarly, you can find upper bound, x bar plus z times s over square root n. You found upper bound. So the final conclusion, what is a population average? The population average between 22.6 miles to 24.4 miles. That is the interval estimate. Any questions? Any questions? All right. So for this example, we calculated the point estimate and the interval estimate. The estimate is actually forecast. Okay, we are doing forecasting. So next question. This question will take okay, maybe we take a break after this question. Or you want to break now? We have this example and next example. Yeah, maybe shall we take a second break? After break, we have 2 examples to go over. Or you prefer to, what do you think?
We can do a break now.
Okay, great. So let's take a 10 minutes break. So come back at 8:18. Break now. Come back at 8:18 to continue. Okay, so I'm going to stop recording. When we come back, I will start with fresh record. Remind me to press record button when we come back. Stop recording.